The year is 1956. A group of brilliant minds gathered at Dartmouth College. They dreamed of creating machines that could think like humans. This marked the birth of artificial intelligence, or AI. In 1997, IBM's Deep Blue defeated world champion Garry Kasparov. This victory was a watershed moment. Despite the excitement, Deep Blue was not truly intelligent. True intelligence, the kind that could reason, learn, and adapt, remained elusive. AI was poised to evolve in ways no one could have imagined. The world of games became a testing ground for AI. Games provide structured environments with clear rules and goals. This makes them ideal for developing and evaluating AI algorithms. As AI research progressed, computers began to excel in increasingly complex games. Checkers, Othello, and even the ancient game of Go fell to the power of artificial intelligence. In 2016, Google's AlphaGo made history. It defeated Lee Sedol, a world champion Go player. Go is a game of immense complexity. It has more possible board configurations than there are atoms in the universe. AlphaGo's victory was a stunning display of AI prowess. It showcased the power of deep learning, a revolutionary approach to artificial intelligence. Deep learning algorithms are inspired by the human brain. They learn from vast amounts of data, identifying patterns and making predictions. AlphaGo trained on millions of Go games. This enabled it to develop superhuman skills in the game. The implications for various industries were profound. Traditional AI systems relied on explicit rules programmed by humans. These systems were limited in handling complex situations. Machine learning emerged as a powerful alternative. Algorithms learn from data, identifying patterns and making predictions. Imagine a child learning to recognize a cat. They learn by observing many examples. Machine learning works similarly. Algorithms learn from data, improving over time. This revolutionized AI. Machine learning excels in image recognition and natural language processing. It powers applications like self-driving cars and personalized recommendations. The future of AI is bright, fueled by learning. Deep learning emerged as a powerful approach within machine learning. It involves training artificial neural networks, which are complex algorithms inspired by the structure of the human brain. Neural networks consist of interconnected nodes, or neurons, organized in layers. Each connection between neurons has a weight associated with it. During training, the network adjusts these weights to minimize errors in its predictions. This process allows the network to learn complex patterns and relationships in the data. The deep learning refers to the use of multiple layers in the neural network. This layered architecture enables deep learning models to learn hierarchical representations of data. Deep learning has achieved remarkable success in various domains. It powers image recognition systems that can identify objects with near-human accuracy. It enables natural language processing models to understand and generate human-like text. The power of deep learning lies in its ability to learn complex patterns from vast amounts of data. Beyond human intelligence understanding, AGI. Artificial General Intelligence, or AGI, represents the holy grail of AI research. It refers to hypothetical AI systems that possess the ability to understand, learn, and perform any intellectual task that a human being can. Unlike current AI systems, which are designed for specific tasks, AGI would have generalized cognitive abilities. Imagine an AI system that can not only play chess at a superhuman level, but also write a novel, compose a symphony, and design a scientific experiment. This level of cognitive flexibility and adaptability is the hallmark of AGI. The development of AGI is fraught with challenges. The human brain is an incredibly complex organ. Replicating its capabilities in a machine is a daunting task. However, the potential benefits of AGI are immense. AGI could revolutionize countless aspects of our lives, from healthcare and education to transportation and energy. AGI in action, transforming healthcare and finance. The potential applications of AGI are vast and transformative. In healthcare, AGI could revolutionize disease diagnosis, treatment planning, and drug discovery. Imagine an AI system that can analyze medical images with superhuman accuracy, identifying early signs of cancer or other diseases. AGI could also personalize treatment plans based on a patient's unique genetic makeup and medical history. In finance, AGI could transform investment strategies, risk management, and fraud detection. AGI-powered systems could analyze market trends, assess investment opportunities, and manage portfolios with unparalleled efficiency. They could also detect fraudulent transactions in real time, protecting businesses and consumers from financial losses. The ability of AGI to process vast amounts of data, identify complex patterns, and make intelligent decisions could lead to breakthroughs in various sectors. The transformative potential of AGI is undeniable. The ethical frontier, navigating the impact of AGI. The development of AGI raises profound ethical considerations. As we create machines with human-level or even superhuman intelligence, we must grapple with questions about responsibility, bias, and the potential impact on society. One concern is the potential for AGI to be used for malicious purposes. For example, AGI could be used to develop autonomous weapon systems that could select and engage targets without human intervention. Another concern is the potential for bias in AGI systems. AI systems are trained on data, and if that data reflects existing biases in society, the AI system may perpetuate or even amplify those biases. Ensuring fairness and accountability in AGI systems is crucial. We must develop mechanisms to detect and mitigate bias, as well as establish clear lines of responsibility for the actions of AGI systems. The development of AGI is a profound technological advancement. Building the brain, neural networks, and cognitive architectures. Creating AGI requires replicating the remarkable capabilities of the human brain. Neural networks inspired by the brain structure have emerged as a leading approach to developing AGI. These networks consist of interconnected nodes or neurons organized in layers. By adjusting the connections between these neurons, neural networks can learn to perform a wide range of tasks. Researchers are exploring different types of neural networks, such as convolutional neural networks for image recognition and recurrent neural networks for natural language processing. Cognitive architectures provide a higher-level framework for developing AGI. They attempt to model the brain's cognitive functions, such as perception, attention, memory, and reasoning. Developing AGI is a complex endeavor. It requires integrating knowledge from various fields, including neuroscience, psychology, and computer science. Learning from